a few MCQ questions from Space Dynamics Part 2. So let's focus on the questions. If the eccentric is said to be hyperbola. So here we are going to focus all about a orbit. Eccentric of an space orbit is said to be a hyperbola. So your options is in your screen. E is greater than 1, E is less than 1, E is equivalent to 0, E is equivalent to 1. Now, eccentric is denoted by the letter E. So, we'll go and see the explanation. Eccentricity of a circle is said to be 0. That means if E equals to 0, that means this is a condition for a circle. The eccentricity of an ellipse, which is not a circle, is greater than 0 but less than 1. So the option where is less than 1, that means it is an ellipse. The eccentricity of parabola is 1. That is, when E is equivalent to 1 or equals to 1, it is for parabola. The eccentricity of a hyperbola is greater than 1. So when the E is greater than 1, it is for hyperbola. So the option is option A. Now comes the problem. Calculate the velocity of an artificial satellite orbiting the Earth in a circular orbit at an altitude of 150 km above the Earth's surface. Take RE, radius of Earth 3960 km. Let's see the solutions. So here comes a given data. They have given the RE. So at altitude 150, so what we have to do to find the radius of that, we have to do 3960 plus 150, we get as 4110 km. So you have to remember this formula, velocity with respect to the mu and r. What is mu? Gravitational constant, or gm. Okay. So if you multiply those, we get this value. You have to remember this formula or it will be given in your data sheet. That is 398600 kilometers square per second square. Please be careful with the units. Kilometer square per second square is a mu value. So you apply, it's very simple, just apply in the formula and R value will be this value 4110, and you solve, you get the answer, that is 9.85 km per second. And don't forget to square root of it, that is 1/2 square root. Next comes a similar question if the eccentricity is said to be elliptical. So already we have studied when it is elliptical, when it is less than 1. So option B. Next comes semi-latus rectum, that is denoted by P, of an orbit defined as, where h is a specific angular momentum, g is a gravitational constant, and m is a mass of the orbiting body. So let's see the solution. So what is mean by semi-latus rectum? It is a component of a Latin word. Semi means half, latus means side, and rectum means straight. So make a note of it. So the answer is answer A, for an orbit. This P equals to h square by mu. But make a note of it, semi-latus rectum P of a parabolic orbit is h square by 2 mu. Please remember, if you see the question, parabolic orbit, it is P equals to h square by 2 mu, whereas a circular orbit or in general P equals to h square by mu. So answer A. Next question, the match the following. Here comes the group 1 and group 2. So here we have to match with this orbits and its applications. What is the application of low Earth orbit? So remember, if you don't know, the low Earth orbits, the application is for mobile communication. So 1 is D. Now you check out here where it's a similarity. Like you can see B and D gives you a 1 and D option. So either the option can be a B or a D. And see, there is another common terms, that is 3. That is 3 is B. It's used for navigation satellite. Now you might be well familiar with a geosynchronous satellite. What is geosynchronous satellite? Mostly we use for weather observation or survey purposes. So 4 comes C. 4 comes C. So option D. So make sure of it. Geosynchronous satellite used for weather or survey navigation or environment observation, right? And Molnier orbit used for communication by polar region countries. So your right answer is answer D. Next comes an elliptical orbit used to transfer between two circular orbits of different altitudes in a same plane. So here you need a energy transfer. So among this whole band transfer, this phenomena or this mechanism is called as a Holman transfer or Holman energy transfer. The option is option B. And down in your descriptions I have given a few ideas about other subjects like aerodynamics, propulsion, rocket propulsion, and you can go down and you can see the link of those description. Now comes the last question of this section. The period of geostationary artificial satellite is. So how long it takes? It takes for 24 hours. It is constant. When comes a geostationary satellite, that means it is 24 hours. The answer is C.